Hello, in this video I'm going to show how to complete derivation 240, which has been a homework problem, and enables the NC rule, which is a really useful rule, letting us turn the negation of a conditional into a conjunction. This is a biconditional, so we're going to show each of the component conditionals. I'm going to do this twice. I'm going to do it first with the MC rules, the derived rules, and then I'm going to do it without. Okay, so we want to show, we have the negation of this conditional as our assumption. It's the only thing we've got. We can't do anything with that, so we need to do a subderivation, and we'll show the consequent of line 2. Well, this is a conjunction, so we want to show both of the pieces. And so we'll show one conjunct and then the other. So we have show P, we're going to assume ID. I'm going to use the MC rules here, and one of the MC rules says if you have a conditional, if a conditional has a false antecedent, then the conditional is true. So if not P is true, then P is false, and so any conditional whose antecedent is P is also going to be true. So in particular, the conditional whose consequent is Q is true. So we can go from this to that using MC, and that's handy because line 7 contradicts line 3, and so we bring line 3 down and we have an indirect derivation, just going from here to there. And we'll do a similar thing with the other conjunct. So we're going to show not Q this time. We'll make an assumption. And again, we're going to an indirect assumption, and we will again apply MC. This one we're going to say, well, if the consequent of a conditional is true, so if Q is true and then a conditional has Q as a consequent, then it's true because its consequent is true. Well, whatever the antecedent is, it's still true. So if Q is true, then the consequent of this conditional is true, and so this conditional is true. Good. Again, this contradicts R, or at line 3. So again, we have another indirect derivation. We will stick 5 and 10 together, and that's a direct derivation of line 4, and 4 is the consequent of 2, so we can use 4 to box and cancel line 2. Now we will do the other conditional. So again, we're trying to show a conditional. We'll assume the consequent, the antecedent. We can split this up, but that's all we can do. So we're going to show the consequent. This is a negation, so we'll assume its opposite for an indirect derivation, giving us if P then Q. So we can apply modus ponens to the P on line 20, and our conditional giving us Q. We can repeat the negation Q, giving us our contradiction for indirect derivation. 22 is the consequent of 18, so we can box and cancel 18 by applying CD to line 22. We now have both of the conditionals, so we will slap them together to build the biconditional, and we are done. Great. Let me show, now we can also do this part, the first part, without using MC, and I will show you how to do that right now. We want to see how we can do this without MC. What we basically do is end up recapitulating, redoing the derivations of MC, but we can do that. So let's see. We used MC, that's just kind of ugly. We used MC in the first part of the derivation. So let's just actually, this will be easiest. It's going to look best. So we are trying to show P and not Q, and so we're going to show each of those conjuncts. So we say assume ID. This is where we used MC before. Instead, we're going to say show on -3. We're going to say assume CD and repeat R, giving us an indirect derivation. And not 7, we want 3. So what MC did was it let us get if P then Q, we go directly from here to there instead of going from here to there with these subderivation steps. So MC lets us just skip this subderivation, but that's fine. Now we have 8 and 12 ID, okay? And we can get rid of that MC. And we can clear that. And then we'll do the same thing with the second conjunct. Assume ID. Again, we could use MC to get if P then Q, which instead we're going to do a subderivation of if P then Q and repeat R, or repeat Q, excuse me. So here again, we get from Q to if P then Q. When we use the derived rule, we do it in one step. When we use the subderivation, it takes 3 steps instead. But it's doing the same thing. And the derivation that enables this version of MC just does this little derivation that we've done right here. But we don't need to do that. We can just do that subderivation. Again, we'll bring down 3. And we have our contradiction. And so we stick those together. And we have the derivation of the first half. And then the derivation of the second half is exactly the same, and I'm not going to repeat it. So that's how we can do this complete this derivation without using the MC rules. But as you saw, I think the MC rules make it a little smoother.